Okay, good morning, everyone. Previous lecture, we talk about architecture. Moreover, we have the opportunity to review one of the architecture patterns. We talk about model view controller. Key idea, split the project, your system in three big parts, the model, the view, the controller. And the main responsibility for them is all the functionality, everything that the system do, go to the model. Whatever your classes, methods, your code is solving functional requirements, that go to the model. Now, usually to the model, you are going to apply another architectural pattern. There are going to be a lot of classes here, a lot of things happening there. So commonly, you have your model, you apply another pattern, you make divisions of the model. We're going to talk about it. But anyway, the pattern, the model view controller, is isolating, separating the model, the functionality from the view. Everything that is, number one, a graphical user interface, or everything that is creating that graphical user interface. We talk about, in a desktop application, the classes that are inheriting from JFrame, for instance, or JPanel, or all your widgets. That is one scenario. In a different scenario, in a web application, all the classes that are creating the response with the HTML code for the browser, they correspond to the view. They are responsible for presenting the results, presenting the information. Finally, the controller, always working in conjunction with the view. Controller in a desktop application, your listeners, they are the controllers. In other scenarios, like web applications, your controllers, those programs, those links, URLs that you call, and the program that receive that request, and the only thing to do is to submit the request, the appropriate request to the model, to call the method that is going to do whatever you are requesting when you click this particular link. So functionality in the model, controller, the interaction, the view, what the user is viewing, controls, HTML, whatever, three big parts. These two are too simple. They do not need more divisions. Usually, the model is going to need something in a big system. Anyway, we're going to work with this. As a general example, a simple one, the system that we did before, all these factory chain of responsibilities and so on that you helped me to create. If you want to visualize the pattern, the architecture of that system, well, basically what you have is your main was this view. Your main correspond to the view in this model view controller situation. Everything else, the classes that conform the chain of responsibility, the observer that we have there, the factory that we have, all the classes related with the data, obviously, all of them are your model. In this particular example, the solution that I show you, and probably the solution that is common to other projects, we have the view together with the controller. Why? Because the same class, main, that is inheriting from JFrame, the view, is also implementing the action listener for the controllers that we put there. So only one class, having the controller and the view in only one class is common for small projects like the one that we do in the school. Outside, two classes, at least two group of classes. Yeah, that is correct. Remember, in the example that I show you, we need to talk about client-server pattern. But in the example that I show you, I consider the browser, the client, and the server. This is the part that I describe as a model view controller, the server part. So in my example, talking about the browser, are you connecting with my ASU, the server in my ASU? I was talking about this part being model view controller. With the client, You can apply also another model view controller or another architectural pattern. And yes, you can play with JavaScript or other things. So this one is another subsystem, and this one can also apply new patterns for the architecture if it's something complex, or just go directly for the design and establish functionality. Yeah, good. So this is what we have, and this is going to be more or less your architecture for most of the software that you have created before. Moving forward, at least I want to review with you another 3 patterns. The next one, the second one, layer architecture. Key idea with this pattern. In the previous one, the key idea was to separate the view and the functionality and the interaction. 3 things. Here, key idea. You know what? The key idea is to create these layers. The key idea is, I have no idea what your software is doing. I don't know if you are going to have views or if you are going to have interaction with the user and you need controllers. Maybe your application is using the console. This architectural model don't care about the details of what functionality is going to happen, but the recommendation is, you know what? You have a lot of people. You have a lot of classes. Think about each class like this. Guys, the pattern is going to tell you, why not you create labels with them? Labels. Yeah. Some people is going to be there, classes. Some people is going to be there. Some people is going to be here. Think about those like states, like cities. It's like, instead of having this bunch of classes just there without any particular organization, and I do not want to use the MVC, it's like, well, put them in different rooms, and the rooms are consecutive. Put them in different layers. And the only rule here is going to be the following. You know what? Anyone, any class that is here in this layer only can communicate with classes in the layer that is below or above. And the same rules apply for every single layer. You know what is going to happen? If you look at your class diagram, for instance, instead of having this class diagram that looks like crazy communication, everything is connected with everything else, you are following this rule. What you are doing is to reducing the number of elements that can be connected with one particular element. Think about this class here, this guy. In the worst case scenario, if you follow this architectural distribution, worst case scenario, this guy obviously can work with the classes in the same layer. That is for sure. This guy can only talk in the worst case scenario with these 3 here, but cannot be connected, cannot talk with this one here. What you are doing is, and obviously if you have more, it cannot talk, it cannot have connection with the others. The goal of the pattern, reducing the number of connections. Again, if we talk about a small system, do not make sense. If you think about a system with 100 classes, it makes sense that instead of having one being able to connect with 99, when you establish this division in layers, somehow it's going to be connected in the worst case scenario with less than 99. That is the goal for the pattern. That's it, as simple as that. Now, commonly, before the MVC, another version or another possibility for graphical applications is the following. If your system is complex, a common solution is following the layered architecture. Your first layer is the presentation one. The presentation. And this box here can be what we before called the view. And this one here, you can have more than one box in the same level. They are the same layer. This one here is what before we call the controller. The view and the controller together in this model are called the presentation layer. Makes sense, right? I mean, the view is the top. The top is the one that is in contact with the user. And something that we did in the solution that we create for our problem is that we put the view and the controller in the same class. And that happened a lot. Why not to put them in the same module? They are different classes, but let's put in the same package. If we do that, more than a model view controller, we are creating this presentation layer, this level in which we put everything related with listeners and graphical components. And that is fine. I mean, it is not mandatory to use one pattern on the other. But then all the layers below are what we call before the model. All the layers below correspond to the functionality of the system. The functionality, well, if we have a functionality that is complex, quotation marks, in the previous pattern, we just put everything together. Everything is, oh, this is the model, bye. Here, instead of talking about just the model, we talk about several different levels of the model, standard levels. And this is just something that happen a lot. It's an example, but there is no rule about always use 3 or 4 or 5 levels. The architecture is generic. You can customize for the particular problem that you're solving. But one example, something that commonly happens is, well, we can put in one layer, in the one that is below the graphical user interface, the business logic. We call the business logic, or in this example, the business layer, to all the functional requirements. Wait, before you told me that the model are the functional requirements. Here, we're putting the functional requirements in one layer, the business. Model, business, different people create different patterns and they are allowed to use the names that they want. I mean, you can create a fancy name for something that you create, right? So business layer, that business layer is the one having the functionality. Now, if the functionality is in the business layer, what happened with the other layers? Well, all the support that you need to fulfill the functional requirements. For instance, okay, I have business layer, but usually in an application, could be web or desktop, you're going to use data. And in particular, this layer architecture is concerned about the data. The data need to be a different thing that the functional requirements, because for the functional requirements, here, you're performing calculations. You're using the data for something. Like when you access my ASU and you want to enroll in a class, the functionality is to allow you to enroll in a class or to drop a class. That is functionality. But you need support. And that support is obviously a database. In some place, the classes, the professors, your previous classes background are stored. And obviously we need a database layer. Database layer, it could be a real database or it could be used files. Again, in my example with your grades and your enrollment, well, we need a real database, right? We are talking about something solid, a commercial database. But for other applications, it could be use a bunch of files. So Java code that is doing file, input stream, output stream, is the last layer, the one that somehow connect with the computer, well, with the hard drive, or maybe send the data to the cloud, whatever, the data. Now, usually what happens is, okay, if I have a database here, I am going to put in a different layer, a layer that is in the middle of the business and the real database, all the source code that I need to create in order to communicate with that particular database. It's a group of files. Well, the source code is different than if I am using a database and I need to do a connection. Now, the things are a little bit different if I am going to use a database that maybe is local with particular features, or I need to access something that is remote and need to take care of security or something like that. In order to make easy to handle the source code, what I need to do, what is the recommendation of this, is just put the classes or the packages or whatever that are related with using the database, connecting, select, update, delete, all the things that need the database here, all your functionality here. Obviously, your functionality is going to be calling methods here, so you can communicate with this layer. Obviously, this layer, whatever are your methods doing the select, need to send that select to the database. It's communicating here. And obviously, your business logic can communicate with your view. The only thing that you cannot do, for instance, is a direct communication from the view to the database. If you do that, you are not following layer architecture. You can think that this is too easy, but the first example in which the things fail is think about login and password. The first thing that you want to do in a system is authenticate the user. The authentication of the user is going to happen here. Yeah, persistency is all about the connection between the data in the RAM, your data structures, and what do you do with those data in the memory, your data structures, and then move to the database or recover from the database. In my previous example, when you are enrolling classes, every class that you select is in the memory, in a stack or in a list or something. I mean, you can be navigating there, selecting, removing, and so on. And only when you press finish or complete or enroll or something like that, what happens is that all the data that you have in the memory is going to go to the database, and you're going to receive a confirmation with the data is in the database. Similar happens with your exams. You can be moving back and forward doing your exam, answering questions, and all that information in some point is used in the memory of your computer. When you click submit, or when the system with a timer detects some period of time, the system is going to send that data from the memory to the database. And the source code that do all of that is this persistent layer. All the classes that are there, including the timer, is this persistency. Remember, persistence is this quality of one object, one group of data, to survive after the class or the source code that create that data die. Your enrollment, there are objects representing the classes, objects representing you. The idea of storing that in the database is your enrollment, your selection still live after you close your session with the software. So yeah, persistent, the connection between your actions and the database, store the data or recover data that is stored before. Moving forward, if you have a view, you cannot, and I need to insist on this, you cannot access directly the database. The common error is, oh yeah, I am using a layer architecture. I have the top layer that is my view, and I need to do a login password. So I show a window asking for the login and the password. And then in the same class that you ask for that, the same class that is maybe the main and is inheriting from JFrame, you put the source code that create a connection with the database and ask if this login and password are correct. From here, you call a method here. That is not layer architecture. What could be the correct way to do it if you want to follow this layer architecture? Well, the view can only communicate with a class here, which can communicate with a class here, which can communicate with the database. And yes, I know what you are thinking, like, really? Instead of calling directly one method, you are asking me to have all these steps. Well, if the layer architecture is what works with you, if what you want to have is this model, yeah, that is the way to go. Why? Because the key idea is that if I change the database, if I move from one database to something different, if I move from a MySQL database to something that is not SQL, if I move from the database to use files, whatever decision that I take, the key idea of using layers is that the only people that I need to talk about it, the only people in the team that need to negotiate with me, or the only other team that my team need to talk with, is the people that develop this. If we can fix these connections here, we can change the database. If we allow someone in the presentation layer to do a direct connection just for the login and the password, in that moment, we do not have layers, because in that moment, changing the database is all about to talk with everyone. The team that developed this and maybe this, or search in a class diagram or something who is using what, is not layers. So good news, bad news. Good news, this allows us to split things, to separate different elements and to reduce the number of communications. Bad news, sometimes the temptation of just breaking the levels is very, very high. Obviously, you are thinking about performance. Yeah, the performance, calling 1, 2, 3 actions instead of one is going to decrease the performance a little bit. Sometimes it's going to increase the use of memory. But in general, guys, you're creating software, performance versus quality, modificability, extensibility, and reuse. Always, 99% of the time, if you increase quality, extensibility, modificability, reuse, the performance is going to suffer a little bit. In general, if you're using object-oriented paradigm, you will notice object-oriented paradigm versus structural programming. Object-oriented increase all of this, all the quality, reusability, modificability, reuse, but the performance in object-oriented is a little bit not the same that the performance that you can have used with the structural programming. That's it. One thing or the other, and usually you need to balance between them. Layer architecture. Good? Any question? Yeah, the persistency is both query or, update, insert, and so on. It's getting the data, query, but also put the data back. Good. So layer architecture could be as simple as this, but you can get something as complex as this. You can have layers inside of layers. So you can have the presentation one, and instead of just talking about your view and your controller, you can create different ones. Remember, these two are connected, and if you put them in the same level or one above the other, the connection is still there. It's usually about what you are doing. In this particular example, always, if you have layers, the layers are connected only when they are adjacent. But when you need to connect something with several layers, some people use these columns. The idea here is this column here can be connected with this layer, can be connected with this layer. You are not doing any mistake. Similar with this column here. When you put a column, the graphical representation is whatever is in that column can be connected with this layer, with this layer, with this layer, or with this layer. The original idea, the things in horizontal, when someone needs to do this connection for something, well, now we have columns. Be careful with the columns. The columns, there are a few moments in which you can justify to do something like this. Maybe the most important, security. When you think about security in a system, You cannot just put security in the login and password that you are expecting to have in the view. When you have security, and in the previous example, it's all about, yes, the access to the interface, but yes, even though I am here in the functional requirement solving operation and so on, sometimes I need to keep the data for the user. I need to be sure that no one accesses here directly. Moreover, with the database, similar scenario, I need security to access the database. I need security for the transactions that I am doing, and so on. Sometimes what you have is, well, you have a framework, a library, or a full group of code that help you to deal with security issues. And basically what you want is to use them, different classes, different modules in the same column, in the same group. And they are going to be dealing with all the different layers. So a column is something that can be connected with classes in the different layers. That is fine. Usually something like this only for very complex systems. And you need to think about a very good justification, because then if you change this column, obviously all the people involved in the different layers are going to be involved in fixing those connections when you decide to change this. Obviously you have two sizes. You can have columns here, columns there, and you can have more than one. You can have layers inside of the layers. It's very common to put, like, if this layer is supported by actions in other two, you can put this like 1 and 2 below. The graphical idea is the 2 below are the pillars, the support from the one above. The size do not represent anything. I mean, you can have this box very, very small and the other large. Usually that do not mean anything. It's just these two are supporting the one above, and you can use colors to reinforce the idea, like, okay, these two layers are inside of what we are calling the service layer, and this column and these two layers are inside of the business part. The data is all about these two components. We split in two, and well, the database is always down. The user is expected to be at the top, and this is expected to be the presentation layer. How many layers you can have? As many as you want. Common example, like in the previous one, presentation, business, persistency, and the data. That is very, very common, but here you have an example that is a little bit different. Common representation before the model view controller, the layer architecture. These kind of diagrams are the ones that we usually connect with the idea of architecture of a system. These boxes inside of boxes and one above the other layer. In an example that is a little bit more simple, here, if you think about the one that I described before, the one that we did, well, we have the main, and we talk about the main being the view, and we have together in the same file also the listeners. So that file, the main, is not only our view, but if we think about applying this layer architecture, that can be our first layer. That can be that file in our simple example is our presentation layer. The presentation. Now, if we think about the others, this was our model. Our model, the only thing that I get if instead of using MVC, I decide to use layers, is that I can have all the functionality in one layer. The functionality in my example was use this chain of responsibilities and the observer playing with these objects. The only thing that I do here is, well, you can have the business, the presentation, and the recommendation of the layers is your data is a different layer. Your data should be in a different group of classes, in a different package or whatever. My data is coming from these classes and the factory. You can think about this one, the factory and the products, like this data layer. I am not using a database, so this could be used my persistent layer. In this case, there is not going to be persistent, so you can use name data layer. The only thing that happened, if I really want to move to this model, is right now, if you review the class diagram, the main is the one creating this one, the main is the one creating this one, and the main, the view, is the one calling the factory to work. So right now, the implementation that we have is model view controller, the main, the view communicating with the model, all the classes in the same way. If we want to move to layers, the first thing that we need to do is to remove this connection. We cannot allow the view communicating directly with the factory, creating a product. The change that we can do is, well, don't worry, instead of asking the main, asking the factory to create a product, the main giving that product to the chain of responsibility, those two actions are in the main. Something that we can do is, well, the main is just going to ask the chain of responsibility to do something. Remember the envelope decoration thing. And if we put this member in the chain of responsibility to call the factory, do you remember create a product? Instead of calling create a product in the main, you call create product in the same place that you are creating the decoration. Product and decoration, same place. And I put together. If those calls come from here, you eliminate this connection. And now we can talk like, yeah, the implementation looks like or can work as an example of a very simple group of layers. In the first layer, the main with the view. In the second layer, the actions, the chain of responsibility and the observer. They are doing something, functionality. And down, my factory creating objects. The only communications, the factory with the chain, the communication between these two is in the same layer, and the communication between this and the view or this and the view, they are correct, they are layers, they are adjacent, they can communicate. So if I want to use my previous example with layer architecture, I need to change this call of the methods, and it can work as an example. Obviously, I am not using databases, it's too simple. I can keep it as model view controller instead of this, but just for you to know. Layers, next, Blackboard. The other two are all about how we organize the structure of the software, the structure, where we put things. Let's talk a little bit about behaviors in the architectural level. Behaviors in the architectural level. The first pattern, the common one for behavioral things in the higher level is the Blackboard. The idea with the Blackboard, in some books, you are going to find this like the repository pattern. Blackboard is a little bit more common, so I give you both. The Blackboard, general idea, your system is going to be as follows. You are going to have a common place. And remember, this is one class, one package, or a group of classes, a group of packages. We do not know. But you're going to have a place, and that place is going to be the equivalent of a Blackboard in a classroom. It's going to be a place in which you can put information and recover information. And I need to be clear. I am not talking about a database. I am not talking about storing data persistent. I am talking about a place in the memory. It's a program running, and in runtime, there is one class or a group of classes that are responsible for storing in the memory the data that others are going to be using. The classical representation of this is a data structure. It's a model that is going to deal with the data structure, the core data structure for the system. Okay, the Blackboard, a data structure, good. What else? Well, in a classroom, you have students. Here, we're going to call it sources of knowledge. those students, those sources of knowledge are going to do two things. They can put information in the Blackboard, or they can take information from the Blackboard. The students cannot talk among them. There is no connection between this one and this one, or this one with any other of the classmates. It's a classroom. We have students. The students cannot talk between them. The only thing that they can do is read the Blackboard or put something in the Blackboard. It's a central place for storing data, but also is the central place for communication. The only way to communicate with others in my classroom is to put something in the Blackboard. Finally, I have a professor. Well, we're going to call it a control. In some books, a leader. The leader, the control. This cannot communicate with the students either. As you notice, there is no arrow. The only arrow is control, just like the students. The only thing that can do is put things in the Blackboard, read from the Blackboard. It's a 100% centralized approach. The repository, the Blackboard, everyone can put data here. Everyone can take data from here. And everyone, two categories, several sources of knowledge, several experts, in my example, students that can be reading and writing in the Blackboard, and one and only one controller, one and only one leader that can do the same, put and read data in the Blackboard. Can you think about one example in which this kind of architecture work or can be used? What kind of software work in this way? What kind of software work in this particular approach in which we need to store data in a central place and several different processes, part of the system, are using that data, doing something with the data, and someone is somehow taking care of what is happening? Well, GitHub could be a good example if we talk about the data here being persistent. But remember, this pattern, what we are talking about is no persistency involved. This is something that is running in the computer, in the memory. When the program finishes, the Blackboard is going to be clean. So without involving repositories, databases, nothing like that, what kind of software work in this way? Control is like the professor, is the leader. I am going to give you the example in particular. Think about a classroom. We have students, we have the professor, we have this common place for the data.
Could Zoom be one? I mean, without like recording the lecture, technically? Because I mean, if you don't record it, everything is deleted after, and there's only one control usually. Yeah.
It's a good example for the control. I have the control, right? And it's a good example for the data. The data is the video that I am streaming probably, but I am missing the expert. Let me give you the example, because something that usually happens is that we think about these boxes here being people. The idea of the pattern is these boxes here, all of them, they are software. Let me tell you this. You have your smart car, or you have your picture, whatever, artificial intelligence. This guy here is a video, like the Zoom one. This guy here is a picture or a group of pictures. You want to know if that picture have inside a cat or a dog, or is a smart car and you are driving, and you have pictures of the video of what is happening on the street. And you want to know if there is a person walking. You want to know if there is someone in a bicycle. You want to know if there is another car. You want to identify things. You want to do things with the data. What is the data? The picture. What is the data? The video. And what you have is different experts using the same video, the same picture, but maybe looking for different things. So this is the guy looking for the cat and the dog. This is the guy looking for another car. This is the guy looking for, and you can put whatever you want here. Think about of the software that classify your pictures. Think about what happened when you upload a picture of something to Facebook. Picture go up. The picture is something that go to the blackboard. Here is your picture. And suddenly, in a second, you have recommendations about which is the name, which is the person that is in the picture, or what do you have in the picture. You know what happened? You can imagine that when you upload the picture go to the blackboard, and you have this classroom of students, and all the students are looking to the same picture and searching or trying to figure out who that person is. Searching in your contacts. Oh, that one looks like this one. Those are the experts. Or in the car, you have this video of the street. A video uses a bunch of pictures. And someone is looking for animals, cat, dogs. Someone is looking for people. Someone is looking for bicycles, motorcycles, other cars, maybe some lights in the streets, some symbols in the streets, numbers. Those are my experts. Those are my source of knowledge. And the blackboard is the data. Makes sense? So what is going to happen? These ones are reading the picture, and each of them is going to report back to the blackboard. And in some place in the blackboard is going to report the result. You know what? What I get from the picture is 2 cats. No, wait. What I get from the picture is those 2 are not cats. They are 2 people. No, wait. There are not 2 people. It's only 1 people with 1 mirror. All of them report results. This guy, the leader, the professor, the one taking the decisions, the one that is only one, what he's going to do is to select which is the answer that we are going to present to other systems. For instance, which is the answer that we're going to send to the view. Because here we do not have a view. I am not talking at all about a view here. Maybe the control is the view. This is the one taking the decisions. Taking the decisions, which is the picture that we're going to put here. How many times I am going to wait for get results? In which point I am going to remove the picture? When I am going to clean the whiteboard, the blackboard. Okay, all these students answer, which is the best answer? Maybe I use which is the answer that is more common. Okay, most of the people tell me that there are 2 cats there. That is the majority. That is the answer that I am going to show to the user. That is the kind of work, that is the kind of software that we solve with this. Data, processes working, one leader taking the decision. Never, 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 there is communication directly between the source knowledge and the control, or between the knowledge source among them. All the communication in a central point. Makes sense, guys? Okay. Let's think about the good and the bad things. Good things is a very nice way to have a central point of control to do collaboration without connecting this one with all these classes. Because you can imagine the class diagram. It's like this one is connected with all of those, this one is connected with all of those, and it's kind of in a classroom asking all the students to agree in something. You know what? Each of you solve the problem, each of you put your result in the whiteboard, so the only flow of things is between you and the blackboard, and then someone is going to decide the final answer according with whatever criteria I have, and I apply with the partial results in the blackboard. Disadvantage, obviously, you can imagine what happens if the blackboard in the classroom is gone. If someone break the blackboard, everything crash. If we lost the blackboard, we do not have the picture or we do not have the video. So all the experts do not have material to work. Moreover, if they already work and we do not have the blackboard, they do not have any way to report results, to communicate results with others. Centralization, that happened. Software, any pattern, any approach, centralize it, one point of failure. Anyway, from the architectural diagram to the design. Help me, what could be the easy way to program the blackboard pattern? If I ask you to create a program, and that program is going to use something like that, a common source of data, numbers, and several different experts working with that data, and then this one and only one leader taking decisions. Can you imagine the class diagram for that? Because be careful, this is not the class diagram. These are just the explanation of what is going to happen. The class diagram is going to be very different for this. Class diagram. Yes, answering the question, this guy can put something here in a particular place, in a particular position, and whatever is here is available maybe for this one. So maybe this one was a message for this one. The bad news is this one have also access. The idea here is you want to talk with your friend, and because you cannot talk directly, you're going to use the blackboard like an intermediary for communication. Yes, you can do that, but you need to be aware that whatever communication you're having with your friend is also visible for everyone else. Or at least that is the idea with this kind of approach, right? Is I put something here and even the control have access to that communication. So that is the point. But yes, you can use the blackboard to communicate with another guy. Now, class diagram, going back. What could be the class diagram for that one? What could be the class diagram if I tell you, you know what, I have a common blackboard, the blackboard could be a stack, and that stack have numbers. And then I am going to have several experts, and the experts are going to do something with those numbers. I do not want to give you a particular requirement, but they are going to be doing something. And then they are going to be reporting results back to the blackboard. And then there is going to be something else, the controller, and the controller is going to review the results and maybe do something with the results, an average, or select one of them. That story that I described with the pattern, my question for you guys is, can you imagine a class diagram, moreover, the source code for something that works in that way? Similar approach to what I showed you with the layer and with the model view controller. I showed you this crazy, simple, trivial software, but I show you how they connect to create the architectural pattern. Can you think about something, the classes that you need, the software that is needed for the blackboard? And in particular, I am going to give you this homework. If you think about a piece of software in which I am asking you to have a class blackboard, I am going to keep this simple. So we need a blackboard. Instead of a package or something complex, I am thinking just in one class. I am thinking about one class student. My experts are going to be students, just to keep this idea of the classroom. I have a controller, and I am going to use this idea of the professor. The professor is the controller, and maybe my main could be classroom. What I need to do to have students that can be working all of them at the same time. Moreover, what I need to do to have the professor and the students working at the same time. And in this point, I am talking about concurrency. A key idea in the Blackboard pattern is the people, the expert, and the leader, they are working at the same time. It's not like one student working and everyone else is waiting, and then another working, everyone else waiting. It's like all of them are working at the same time, and the leader is watching things at the same time, just like in a classroom, right? Programming, Java, what do we need to make these guys concurrent?
Runnable.
Thank you. So, homework, because I need to stop here. Can you imagine the class diagram for connecting these 4 classes? Which are going to be the connections? Moreover, what do I need to add to the class diagram and to the source code? Runnable, the interface, where, how? Think about it, and we continue next lecture. Good? Classroom is the one that have the main. Basically, Classroom is the main. I need to put the main in some place, so I have 2 choices. Maybe the main could be in the Blackboard. It could be a little bit weird, so I just create another class that have the main. That's it. Good? Okay, guys. See you Friday. Thank you.